speaker, and I suppose I could go on all night with her background. Just a few highlights. Well, first of all, she's a mother of two. I don't know how she squeezed that in. She got her bachelor's degree from Brown University and her PhD from Duke University in biomechanics. Think about that. How do fish propel themselves? And now she makes films, does all kinds of things. I'm not going to go into all this, but there's a chapter of Earth Heroes called Champions of the Ocean. She is certainly one of the champions for saving the ocean. And also she's profiled in Girls Research, Amazing Tales of Female Scientists. She has a website, maybe she can tell you about this. It's a game called Animal Jam. It's for 6 to 9-year-olds, so look it up when you get home and play it. I think you become some kind of animal and go into the Tierney aquarium. She was actually born, I should say, she's born in California but lives in Carmel, and somehow does all these wonderful things alongside being a mother. And it's really hard to find role models these days when you look at all the news or the politicians, but if you want a role model, Tierney is one of the great ones. So listen to her carefully tonight. I hope you learn from it. Let's give her a very warm welcome by doing the following wave. I'm going to count to 3, and when I do, when I get to 3, please yell, "Welcome, Tierney." Are you ready? Really loud, okay? 1, 2, 3.
Great introduction. Thank you, Steve. And thank you all for coming out. It's a thrill to be here. And I'm so happy to see you all. I look forward to answering questions afterwards so we can talk one-on-one. Well, maybe we should just get started with the first slide. Let me get this down and then get this other copy. It suddenly disappeared off my laptop. Alrighty, a technical glitch, but that's okay. We will find it. This is odd. Sorry, thanks for your... Okay, here we go. All right. Okay, my favorite picture. I love this picture of Earth because it shows what kind of planet we really are. A wonderful, wonderful planet that's mostly ocean. And that blue is the reason why life thrives here and nowhere else, as far as we know in the known universe. Our ocean has kept most of our planet hidden, but all of it alive. It has separated and united the peoples of our planet. It has inspired our nautical and technological greatness. It has provided the protein to nourish our brains. It's the highway upon which we transport 90% of our internationally traded goods. 90%. And it's also, we fuel our lives, drive our cars, with the fossilized remains of ocean plankton. So we owe the ocean an awful lot. Now, there's a lot of ocean projects going out there studying how the ocean works. Just one of them is possibly one of the largest ones, the Census of Marine Life, which began in 2000. And one of the projects I was part of, and that spurred hundreds of projects, hundreds of ocean projects around the world involving thousands of scientists. But we still have so much more to learn about the ocean. And there's so much more we don't know. Scripps recently published what is believed to be the highest resolution map of the ocean floor. And it maps the whole ocean floor with a resolution of about 5 kilometers. Now that's pretty good. It's certainly the best we've got right now. But when you think about it, 5 kilometers is pretty long distance. So within the span of like 3 miles, there could be something in there that we wouldn't see. Be it a big jet liner, you know, like a 777 that's gone down and you can't find it. You could have, oh, is this a bad sound?
Yeah, for some reason.
Yeah.
Could you change the
Yeah.
turn that off?
Okay. You guys weren't saying anything. You were just sitting there listening to that bad sound quality. Okay. Okay, is that better? Yeah. You gotta speak up, say it's over. So you know, it's not bad, 5 kilometer resolution, but when you compare it to, say, Venus or the moon, we've mapped those places with the resolution of 7 meters. So we've only seen less than 90%. We've only seen about 10% of the ocean floor with our own eyes. We have a long way to go. And so if you added up all the parts of the ocean that we have mapped with the same resolution that we've mapped the moon, it would fit into the tiny little space of Tasmania. Do we even know this planet that we call Earth? I think that's pretty exciting, that this planet, we're just beginning to explore it. So why is it so difficult? Why can we map the moon and Venus? Why can we map those surfaces better than our own planet? Why? We live here. Well, it's that darn water. The reason why we live here is because of the water, but the water is what makes it difficult to see through. And it's complicated, even within the water itself. This is a great diagram that shows just how complicated all those processes are. We've got upwelling, we've got wind, we've got all these different transport mechanisms. And the sun is what's powering all of this. The water itself is absorbing 90% of the heat of the sun and 50% of the carbon dioxide emissions. So it's playing a huge role. And within the water itself are these incredibly complicated food webs. This is just one food web of cod, Atlantic cod. It looks pretty complicated, doesn't it? It's like it's very webby in the ocean. It looks like a spider web, like a big mash of spaghetti. And scientists don't even know who eats whom. So there's still a lot to be learned. And if we dive in even closer into this area, we have tons of microbes that are doing all sorts of amazing things that we were just now discovering. 90% of the ocean biomass is microbial. And so we like to think of the whales and the dolphins and the turtles, but the real mega power of the ocean lies in its microbes. And one of them is, you gotta love this one. This one's called Prochlorococcus. Anyone know Prochlorococcus? I think you should all say it with me, because right now your lives depend on it. Can we all say Prochlorococcus? Every second breath you take is breathing in oxygen that this little phytoplankton has been churning out. 50% of our oxygen is made from phytoplankton, and a lot of it is from Prochlorococcus, the most abundant photosynthetic organism on the planet. And that's just one of them. So in the spirit of exploration, I figured we would take a journey together. I actually go on a lot of National Geographic expeditions, bringing guests with me, and tonight I would like you to come dive into the ocean with me, and we're going to take a journey around the planet, around the whole world ocean, powered by the motion of the ocean itself, on the Great Ocean Conveyor Belt. Are you ready? Yeah? Okay, it takes a little while to make a full round trip. It takes 1,000 to 1,500 years. So I hope you're comfortable, because you'll be there for a little bit. All right, so let's jump in. Now this, we're going to jump in from the East Coast. We'll jump into that famous current, the Gulf Stream. And the Gulf Stream, we haven't always had the Gulf Stream. The Gulf Stream arose when North and South America
when the Isthmus of Panama rose up and separated the Pacific from the Atlantic Ocean. And, well, you know, the neighborhood's never been the same since. And that, then we get the Gulf Stream, and we get the circulation pattern that we know today. But the world hasn't always been that way. So now, as we move into the Gulf Stream, we're going to pass what used to be the most booming fishery known in our history, and that was the cod fishery. 500-year-old fishery. It's actually what inspired the discovery of North America, was this amazingly productive fishery, the cod fishery. Unfortunately, we overfished it in the 90s, and it's never recovered since then. But we do have some good news when it comes to fisheries. For instance, due to the Magnuson-Stevenson Act, which sets strict regulations, it's all science-based. Science is really needed for us to be able to make these quotas and have fisheries be healthy. And the Magnuson-Stevenson Act has been very important in doing that. And because of that, we have fisheries rebounding, like the black sea bass, the mid-Atlantic bluefish, and menhaden. And we're getting our fisheries in order. And we're getting some new fisheries, like, for instance, these jellies. Did you know that the jellyfish are now the 3rd largest fishery in Georgia and South Carolina? So as we pull out high-calorie food fish, a lot of times jellies will move in, but we make them into a fishery too. So we're getting our house in order, but unfortunately, globally, that's not the case. 2/3 of fisheries globally are overexploited, and 2/3 of our marine predators have been consumed, really just in the last 100 years, and most of them in the last 40 years. So that's the rest of the planet is not following suit in terms of getting their fisheries in order, but that doesn't exonerate us. We play a huge role in global fisheries because we import 90% of the seafood that we eat. 90%. The choices you make at the supermarket play an enormous role in the health of fisheries around the world. And furthermore, that 90%, more than 20% of those fisheries are fish, of that fish are caught illegally. Pirate fishing. It's a huge problem. So you may be ordering something at the market or at a restaurant, and when it arrives at your table, it'll already be, you know, most of it, 20% of it at least, will already be poached. Maybe you like it cooked a little differently, but it will be poached. So that's something to bear in mind. We can have huge impact with the choices we make in the market. So, if there's anything you remember from today's talk, this is the slide to remember it. Eat more veggies, just like your mom always told you to. Veggies are really good. You don't have to eat a lot of fish, a lot of protein. But if you do eat fish, then the kind of fish, not all fish are created equal. There are some fish that are better to eat than others. For instance, you want to eat fish that eat low on the food chain, not top predators. It takes a lot of biomass to make a top predator, like a tuna, or a marlin, or a halibut, or things like this. So you want to eat fish that are low on the food chain. And you know how the Surgeon General is always telling you to eat fish because it's got those long-chain fatty acids, those omega-3 fatty acids? Fish don't make that. They get it from the algae they eat. So you could bypass the fish if you wanted to and get it from the algae instead. There's another problem. Now, let's say you all want to make the right choice and get fish that are sustainably sourced. Unfortunately, there's a lot of seafood fraud that goes on. There was a study that came out recently down in Los Angeles in sushi restaurants that 50% of the fish that were being served were mislabeled. So that's a big problem, and being able to track the seafood, where it comes from, so that we hold the distributors and the marketers accountable for what they're serving is certainly a big priority. There's some really interesting innovations that are coming out now, and this one this one I'm excited about. It's called MinION, and it's a handheld genetic fingerprinter. So ideally, you'll be able to take small samples of fish protein and fish muscle and be able to genetically identify it so that you know what you're buying. And that tool will be available to suppliers and distributors so they can keep track of what fish they're selling and where it comes from. So technology can help us, give us the tools to help us make better choices. I get asked a lot about aquaculture and the pros and cons of aquaculture. Well, I think aquaculture is a phenomenal way of getting protein to the masses if done correctly. And there's some great examples of aquaculture being done correctly. And some of this is what we call three-dimensional farming. Farming multiple species, essentially creating a whole ocean ecosystem within your farm. We see this on land with things like polyculture, where you're able to farm at different levels, from fish to plants, and essentially harvest from every trophic level. But we do this in the ocean, and these farms are now popping up all over the world. One great example is up in New Brunswick. There's another one off of New York, and they're by farming in this way, including kelp and seaweed, it actually enhances the health of the ocean and helps filter pollutants out while providing a crop as well. So another great solution to providing protein and making the ocean a healthier place. Okay, so let's continue our journey on the Great Ocean Conveyor Belt. And the way the Ocean Conveyor Belt works is that we have warm water that's moving up into the northern reaches. And as it moves up, it's getting colder, and the winds are evaporating it, and it's getting denser, and it's starting to sink. And that sinking, we call that deep water formation. That sinking is propelling that great conveyor belt that will take us around the world ocean. So as we've gone up and around Iceland and down past through Greenland, we're going to stop and check out the largest waterfall in the world. And that picture is not it. Because unfortunately, the largest waterfall in the world, you can't see it because it's underwater, of course. But it's called the Denmark Strait Cataract. And it dwarfs Niagara Falls, 20 times the Niagara at peak flow, 200 times, I mean. So another part of our mysterious ocean that's hidden to our eyes. So continuing on, we will travel down the longest mountain range in the world, the Mid-Atlantic Ridge. This is an amazing mountain range. It's 10,000 kilometers long, and it's also an area where we have seafloor being created from the bowels of the earth, conjured up. It's what's pushing the continents apart. The discovery of the Mid-Atlantic Ridge was actually helped the discovery of plate tectonics. So if you have, it gave Christopher Columbus a reason for being. Had we not had this spreading center, we would have kept our continental masses together. But the Mid-Atlantic Ridge is spreading us apart about the same rate as we grow our fingernails. And it also is housing amazing life that doesn't even need the sun to live. And as we continue down, we're going to pass by West Africa. And here we may encounter some industrial fishing fleets, mostly from China and subsidized by the European Union as well. And these fishing fleets are busy stripping protein from the West African coast. Now, what happens when that goes on is you're cleaning out that protein supply, and that's being sold globally. And that protein supply has to be made up for by the people living in Africa. And so we see direct correlations for when fishing plummets On the West African coast, we see poaching increase inside Africa. So there's a direct correlation with where the protein is coming from. We need healthy fisheries in order to keep the big five and all those beautiful African animals alive and healthy as well. So that's some really interesting research coming out of Cal Berkeley. So continuing down around, we will continue our journey down and into the great circumantarctic current. That'll take us around and up into the Indian Ocean, past Madagascar, and there is a Mauritius, a new underwater continent that was recently discovered, past Bangladesh, which may be underwater if we keep up our global warming, and down along, around Antarctica, and on the way, we're probably going to be passing a bunch of these floats right here that look like this. This is a critical tool for us to understand the ocean, because remember how I said the water is what's keeping it hidden from us? Well, now we have these floats called Argo floats deployed. There's about over 3,000 of them that autonomously swim through they float through the ocean, drift through the ocean, and go up and down, sampling the ocean, and then wirelessly sending all that information back. So that is a critical tool for us to understand what's going on in the ocean. So we'll probably pass lots of those, and then continue along around Antarctica. And we may, as we go into Antarctica, we may hear some interesting sounds. Now that sounds like something out of outer space, doesn't it? But that is actually the sound of a Weddell seal. And they can sing for up to 2.5 minutes. Pretty interesting sounding. Now the current of Antarctica that goes around, so this is the largest ocean, and it connects all the ocean basins. It's the flywheel of Earth's climate system, and yet it's the least understood. But its role, it's been keeping the warm waters away from Antarctica, but that's becoming a little more difficult now as we continue to warm the ocean. And here, 2 recent big studies showed that underneath, that right over the West Antarctic ice shelf, we have the Thwaite Glacier, and that is being undermined by climate change. And it's just a matter of time until that huge part breaks off. And when that happens, we're going to see sea levels rising by upwards of 2 feet in the next 150 to 200 years by all predictive models. So that's something that we need to prepare for and accordingly. So as we continue along, we will then move past one of the most productive currents in the world ocean, the Humboldt Current, and past Peru and into the absolute epicenter of marine diversity, the Coral Triangle. This is a place where we have, 500 different species of coral and 3,000 different species of fish, every kind of sea turtle except one, and it's where all sorts of marine biologists love to do their studies because it's warm, easier to study there than going into the Arctic and the Antarctic to study. But what's exciting about these areas is that people, island nations are really protecting their resources and discovering that it pays more to protect your resources than to sell off fishing rights. For instance, Palau, Tommy Remigasau, who's the head of Palau, he's decided to ban all commercial fishing in Palau. And so now, and pretty much 80% of all waters are protected. And he's found that instead of with tourism, we can get $85 million worth of tourism dollars a year, as opposed to fishing, which only brings in about $5 million. So now, and we're seeing one-upmanship in nations around the world now, creating larger and larger marine protected areas, like we've never seen before. So then the question gets to be, how do we protect these areas in such large masses? Well, this is where we've got technology on our side, and a lot of it's coming out of California and Silicon Valley. So things that I get really excited about are these tiny little satellites that we can put into the sky, and they can be our eyes in the sky to help remotely police huge expanses of the ocean that have now been cordoned off as marine protected areas. So they're not just paper parks, but actually real parks. So we've got the satellites in the sky, and we've got drones in the water. This is a great drone, the Liquid Robotics Wave Glider, and it's powered by the motion of the ocean as well. It's got these, the way it works is that it's got it's like a surfboard on the top, connected to a cable, which is then connected to louvars that can move. And with the motion of the waves, it pushes those louvars up and down, and it can move on its own, just from the movement of the ocean itself. And it just recorded crossing the Drake Passage across the Southern Ocean, which is a nefarious seafaring, eating. Drake Passage is just a really difficult ocean area to operate in, and it made its way over, and it's sampling the whole way. So that was developed right in the Bay Area here in California. And then sail drones as well, they move a lot quicker, and it's pretty much just an autonomous sailboat that goes and can sample the ocean and relay that back. So we've got the satellites in the sky doing remote sensing. We've got on-the-water surface drones. And then just slightly above, we also have lower flying drones, like these ones, these low-cost unmanned aerial vehicles. So these are the kind of drones that I think make good news headlines. And they can carry some pretty interesting machinery on them. There was one some friends of mine developed, and they called it the Snot Bot, because it had a cool little sensor on it, and it could fly next to whales, and when the whale came up and blew, it could gather that snot that came out of the blowhole of the whale, and then measure the stress levels of the whale accordingly. So how would you like that to be your PhD thesis? Yes, what do you do? Oh, I gather whale snot and make sense of it. So now you've got all these tools. You've got the satellites, you've got the drones at different levels. So then you can combine all those. And Pew Charitable Trust has this, one group doing this. And you get all these and also a critical part of this is that fishing vessels have a reporting system that they're always pinging out, that the satellites can be picking up, the Automatic Information System, AIS. And so when fishing vessels turn that off, because they're doing something naughty, like illegal fishing, then that can set up a red flag. And then that can be monitored remotely, no matter where you are. You can be monitoring the waters of Palau from your couch in England and see what's going on. Google is also getting in on this, and they've partnered with SkyTruth. And now I just read that Paul Allen's ponied up about $40 million to do another system. So there's redundancy now in multiple groups combining these technologies to police these large areas so that you actually are having a marine protected area, and not just saying that you created one, but actually making it a reality. So this is great news. When I started in marine conservation, there was not this kind of momentum at all. It was a slog, and it did not look good for the ocean. But now there's huge momentum. If you were to graph it, you would see the number of marine protected areas is on this steep incline, and nations are sort of vying with each other. No, I'm putting in a bigger one. No, I'm putting in a bigger one. That's the kind of competition we love to see in the conservation world. And so now we have, we have something, over 8,000 marine protected areas. And just like 5 years ago, I was saying, we have less than 3% of the ocean protected. Now we're up to 6%. So we're making steady headway, and it's such an exciting time to be in studying the ocean and to be in marine conservation. So let's continue on our journey out of the Pacific, and we will now there's a part when we were on the conveyor belt, when we went through Indonesia and into the Coral Triangle, we kind of bypassed this whole big part of the Pacific that will take us to our coast here in California. So we'll backtrack a little bit, and we will go up that and land up there in Hawaii. And one of the largest marine areas that was created, started by George W. Bush, and then expanded by Obama, Papahanaumokuakea. And I'm going to test you to see if you guys can say that at the end of it. It's a great, huge marine protected area now in the Northwest Hawaiian Islands. But when we go up there, we're going to be going through an area of a lot of plastic trash. So how many of you guys have heard about the Great Pacific Garbage Patch? Yeah. So that's gotten a lot of press, as well it should. Now there's not just one in the Pacific. Every ocean gyre has a lot of trash in it. We call these the toilets that don't flush, unfortunately. And it's a pretty sobering thing. All the plastic we've ever created, since the 50s, none of it has degraded. It has broken into small pieces and then gotten into the food web. A lot of that is fibers from our clothing, as well as single-serving plastics. So it's a huge problem. And it's something that we can all play a part in reducing by saying no to single-serving plastic and bringing our bags to the grocery store and, figuring out different clothing to wear. But I think, as opposed to thinking of it as, and then of course, before I go to that, the horrible part of this is that the plastic floating on the surface is then mistaken for food and eaten by birds, and that's the first meal that they give their offspring is often a big chunk of plastic. Now you think, well, those birds, why don't they learn? After all this time, we've been putting plastic in the ocean for a while and it's getting thicker and thicker. You'd think those birds would learn, but the tricky thing is the plastics, they're not just, the birds aren't just going to them thinking they're colorful and wanting to eat them. What happens is that algae settles on the plastic. It's new real estate in the ocean. Algae settles on the plastic, and when you get a lot of UV light on certain algae, they start to put out something called dimethyl sulfide, DMS. That smells like food to seabirds. So, unfortunately, the plastic is smelling like food to them, and they're eating it. So there's all sorts of knock-on effects. Also, these plastics are concentrating persistent organic pollutants like DDT and PCBs. So they're not just obstructing digestion, they're actually little poison pills. So you could sort of throw up your hands and say, oh, plastic, it's so ubiquitous. What on earth are we going to do? But there's hope. I have a lot of hope when it comes to plastic, and I view it not as the bane of our existence, but a huge entrepreneurial opportunity for finding new materials to replace plastic. And there is great momentum for doing this. And there's momentum to change our plastic habits. Like, for instance, plastic bag bans. They're spreading across the planet. Even here in California, we have plastic bag bans. How many of you guys bring your own bags to the grocery store? Ah, this is a great audience. Yeah, and so every little bit you do makes a big difference. And I have the pleasure of announcing a new A new building and a whole new institution is opening up at Cal State Monterey Bay, underwritten by Sam Farr and his team. And this is with a group that I'm on the science advisory board called Think Beyond Plastic. We have an innovation challenge where it's like X Prize, where people who are coming up with new materials, bio-benign materials, can enter the competition, and those who win then get to come to the Center for the New Plastic Economy and test out their products. We'll have big machines to sort of test it at commercial scale, and work with startup groups in Silicon Valley to help them scale up these new products. So this is really a golden opportunity for change making, and certainly you'd have job security if you could come up with plastic replacement. So great new innovations happening right here in California, just a little bit down the road. So I think this area is becoming the hub for solutions. Incidentally, the founders of Think Beyond Plastic were just in Malta, and about $8 billion was pledged for ocean protection at this meeting, the Our Oceans meeting in Malta, which just happened last month. And I think 240,000 square miles of new marine protected areas. So we're on the up and up when it comes to ocean conservation and ocean solutions. Okay, so continuing on, we'll pass Hawaii. We'll come down. This is probably starting to look familiar. We got the California coast there, little Baja down there. Now, one thing to know about the ocean is all the waters are different. The waters in the Pacific carry the oldest ocean waters. And the older waters are also are more corrosive, have a higher, are more prone to ocean acidification. And that is a huge problem. Now, if you don't, the mechanism of ocean acidification is that we're putting a lot of CO2 into the atmosphere, and that dissolves into seawater, and when it dissolves into seawater, it becomes carbonic acid, and that changes the pH of the ocean. So the pH has shifted it's 30% more alkaline, more acidic than it has been. That doesn't seem so big a change, but that's 100 times faster than we've seen any chemical change in the ocean in the last 300 million years. So that is a huge elephant in the room, is how the pH of our ocean is changing as a result of sinking 50% of our carbon dioxide emissions. The ocean plays a huge role in doing that, but it's not without a cost. And so by changing that chemistry of the ocean, that has dire repercussions for animals that precipitate out calcium carbonate for their shells. So things like these little oysters and pteropods, these little sea butterflies, coral reefs as well. It makes it much more energetically expensive to make your shells when your pH is just a little bit shifted. So Taylor Shellfish Farms, that's our largest shellfish distributor in this country, has now sent its oyster larvae off to Hawaii, to a better area for the larvae to grow than off the coast of Washington. So this is certainly something that we're tracking. And a study that was just recently done down the Oregon and California coast was measuring these little pteropods, and they're called sea butterflies. They make up a huge portion of the food for salmon and things like this, and they had all these little pock marks in their delicate little shells, and that was a lot larger a response to ocean acidification than what was previously thought. So how this is going to affect a lot of the megafauna is still being studied. But I love this slide. This is a slide that came from the Census of Marine Life. And I just had to put in the ocean sunfish. That's one of the animals that I study, and I have a particular obsession with these animals, the ocean sunfish. But this work was tagging Pacific pelagics. And just 10 years ago, we didn't know where all these big animals went, like blue whales and jumbo squid and elephant seals and great white sharks. For instance, these great whites right there, using these kinds of tags, and I'll pass this around. This amazing technology. This is called a pop-off archival satellite tag. It's essentially like being able to put a little travel diary on an animal, and it records its temperature, depth, and then light intensity, and from that and a clock inside, we can get longitude, and we can figure out where these animals have gone. We put it on the animal, it stays on for up to 2 years, and then it pops up, turns on, and relays that whole travel diary to our computers. We never had to see the animal again. Pretty cool technology. They only cost about $3,500 each tag. But thousands and thousands of them have been put out and have allowed us to create maps like that. And so we know now that leatherback sea turtles from Monterey Bay are going all the way over to Indonesia to lay their eggs. And we know that sheer great whites go down to this place called SOFA, the Southern Ocean Feeding Area, and it's kind of like Burning Man for sharks. All these young, mostly males, go down to this place that has no, discernible resources, and they hoop it up. There's just tons of activity. Who knows what they're doing? There's no real ready food supply, but they're doing something down there, and we would never have known that had we not had this great technology to track those animals. So we call it the White Shark Cafe down there. And leatherback turtles and molas. Molas were part of this study. So technology is allowing us to let the animals tell us where the important parts of the ocean are, where the hot spots are, where the best places to eat are, the best places to find a mate, the best places to have summer vacation. We can't protect the whole ocean, but we can find those metropolises that are so important to the animals that live there and let them tell us where we need to focus our efforts. And technology is allowing us to do that, which is terrific. And we have more fun technology like SharkNet, where we can actually use our cell phones to track great whites all along the coast and know where they are, which is kind of a nice thing to do if you're surfing and you want to know who's surfing next to you, especially if it's a great white. Some other great tools that we're using are cabled observatories. Oceanographers often call studying the ocean, they call it paparazzi oceanography. We kind of go out when there's a big event and chronicle it, but to really understand the ocean, you need to be in the ocean 24/7. And how do you do that? How do you stay in there through the storms? That's when everything's happening, is the storms. You need cabled observatories, a power source out there, so you can keep all your equipment out there taking readings. And we're lucky to have one in Monterey Bay. There's one in up off Seattle. There's in British Columbia. There's one off Maine. So having more cable observatories. They're hard to get funded, but boy, are they a huge resource. Now for everyone with a personal computer, you should check out Google Street View. Google Street View is with Caitlin Sea Survey, and they've been taking these great cameras and getting 360-degree views of all coral reefs all over the planet and chronicling that with incredible resolution. And from your desktop, you can just jump in and dive into all these places just from the comfort of your own laptop. So that's pretty cool. And there's so many ways to actually play a part in discoveries that are happening in the ocean right now. Check out SciStarter or SeaHack, and there's all these citizen science or community science projects that anyone who's got an interest in playing a part in doing science can be part of these. Everything from, translating whale songs to identifying seafloor organisms to transcribing old ship logs to get a sense of weather through the ages. All sorts of fun projects. And just about to be released now is a new ROV, remotely operated vehicle, created down in the Bay Area as well. You can build your own remotely operated vehicle that could take you down to 100 meters or so with a high-definition camera. This was developed by one of our explorers at National Geographic. Check out Open ROV, and you could order your own ROV and build it in a weekend and put it into any water mass and explore and not even get cold or wet. Although I think getting wet's a good thing to do. Get your head underwater. And you don't have to be at a university that has, or a college that has any ocean programs, because online courses are available for free. There's tons to choose from, super high quality, with terrific instructors. If you check out Coursera or University of Queensland, all these courses are taught by total marine scientists at the top of their field, and they're all free for anyone to take. So lots of resources online. And if you're wanting to stay up on the latest and greatest ocean news, really terrific reporting, you should check out Oceans Deeply. Definitely write that down if you're interested in keeping your finger on the pulse of ocean issues. That is a terrific website. Okay, so let's continue our journey around as we move, continue on our global ocean conveyor belt. Now it's, we've been traveling a while, we're moving, and it's taken us 1,000 years. And when we come back, what does our world look like, say 1,000 years from now? Do we have coral reefs? Have we lost Manhattan and Miami? Is Bangladesh gone underwater? The Maldives, Kiribati? What does our world look like 1,000 years from now? Well, one thing I know is that I think we need to envision a brighter future than what Hollywood paints for us. Have you ever noticed how Hollywood paints the future? Does it look like a place that you'd ever want to inhabit? We have like the road, we have zombies wanting to eat our children, we have cyborgs, lots of weapons, very little nature. I think that's rather uninventive. I think we need to envision a brighter future, a future that we want to inhabit, a future that's hopeful and beautiful and shows us what we can do right instead of everything that's gone wrong, this dystopian vision. So I'll leave you with a few final thoughts. Our ocean, we are the only planet, as far as we know, that has liquid, accessible ocean water. Now Mars looks like it had an ocean, but it lost it due to solar winds and other forces. And certainly we have, places like Jupiter's Europa or Saturn's Enceladus, and they may have oceans, but they're under kilometers of ice. They're not accessible. Our ocean is the only one that is accessible. And it has been the lifeblood for us. It's provided so much life. 99% of the living space on this planet is in the ocean. If you flip that around, that means we inhabit 1% of the available living space on this planet. 1%. The way to be on this planet is in the ocean. And some of the most amazing things have come from that, like flamboyant cuttlefish. I mean, that you can't imagine things like that. I mean, this is, truth is much stranger than fiction. And sentient beings. We ourselves came from the ocean. And it's not just the whales that have the intelligence here, but we are creatures of the ocean as well. So when we're thinking about this, you know, where in the long arc of history do we want to place our smart selves? It's taken 4 billion years to create the amazing life we have the honor of sharing this planet with. And I think we are in a momentous time now, like never before, with tools we've never had before, to make a difference. I think we have it in us to harness the power of our 7 billion brains, to work together with the ocean, as if our life depended on it. Because, well, in fact it does. Every little action makes a difference. And so I thank you for being here, for listening, for keeping the ocean in your heart and your mind. And together, I think we can make a difference. All we need to do is dive in.